Hey guys, welcome back. We'll continue with the book Cracking Codes with Python, and in this video we're going to learn how to write an automated test program that tests whether our program works as expected. Let's get right into it. We saw that our transposition cipher worked well for encrypting and decrypting a message, but we can't be sure that it will work in all instances. So to make sure that it really always works properly, we're going to write a program to automatically test our code. So before we dive in, if you want to follow along, you can head over to inventwithpython.com. The link is also in the description down below. And let's dive right in by writing our program by opening idle and selecting File, New File. And we're going to save this file as transpositiontest.py. And to start out, we are going to import a number of different modules that we're going to use. This includes the random module that helps us generate random numbers, the sys module, which we can use to interact with our system, for example, to close the program. And then we are going to import the two programs we wrote before, our transposition encrypt program to encrypt a message, and then the decrypt program we used to decrypt the message in the previous video. Once imported, we have a main function here. Inside of our main function, we have our random module, and we call the seed function on it. And we can pass a value to the seed function, an integer value. And this is our starting point, so to speak, for our random numbers. If we know the seed for our random number, then there's a way to figure out what the random numbers actually are, because it's a pseudo-random way to generate them. We're then going to run 20 different tests by using a for loop, and we're going to generate random messages to test our program. For that, we have a message variable here, which are simply the letters of the alphabet, and we are multiplying the string with the random value here, so that we have a message that has a random length. We are then going to take this message with a random length and we are going to turn it into a list of characters. And after that, we are going to use the shuffle function to put the different characters in a random order. And of course, we're going to have a closer look at these new functions in a little bit. Once we've done that, we're going to join the characters together again so that we have a new string generated with letters in a random order. We're then going to print out the number of tests that we're performing out of our 20 test runs, and we're going to display the first 50 characters of our random message. After that, we're going to check all possible keys for each message. For that, we are going to loop over the keys from 1 all the way up to half the length of the message, because we know when we work with the transposition cipher, the key can have a length of 1 all the way up to half the length of the actual message. And then we are calling our transposition encrypt module that we wrote 2 videos ago. And inside of that, we have our encrypt message function that we call, and we pass the key and the message to it. And by doing that, of course, we are going to get back the encrypted message. And after that, we can take that encrypted message, pass it along with the key to our decrypt message, which of course is part of the transposition decrypt program or module that we wrote in the last video. And this way we're going to get back our decrypted message. Now, in the case that our decrypted message doesn't match the original message before we encrypted it, then we know something went wrong. And in such a case, we're going to print out that there's a mismatch with the key and the message. And we're going to print out decrypted s. And then we're using the exit function, which is part of the sys module, to quit our program. Otherwise, if the message is equal to the decrypted message, then we're going to print out that the transposition cipher test passed successfully. And of course, at the very end, we need to have our if statement. So here we're checking if name is equal to the string main. And if that's the case, we're going to start executing our main function here. So let's run our program. And for that, we can select run and then run module, or we can simply press F5 on our keyboard. So let's run our program. And for that, we can select run and then run module, or we can simply press F5 on our keyboard. Now when we run this, we can see we have 20 different tests that are being printed out. So here we are seeing the test number and then the messages here, the randomly generated messages. So we can see the letters are in different orders here. And in any event, we always print out the first 50 characters, even if we have way more characters. And we can see in all of these cases, we get a print statement back that the transposition cipher test passed. We can see this worked for all 20 different iterations, so we know that our program was correct, and at least for those random strings that we tested for those 20 different strings, it worked properly, and the original message is equal to the decrypted message after running it through our encrypted function and then getting our decrypted message back after calling decrypt message. So now we know we have a solid way to test our code, and it seems that our program works properly. So let's now have a closer look at the new concepts we covered by writing this test code. And the first new concept that we covered was working with pseudo-random numbers. We imported the random module before, and the random module contains a number of different functions that we can use to generate numbers that appear to be random. They're not actually random. There are some mathematical functions that can be used to get pseudo-random numbers, so numbers that act as if they were random. And the random module contains a number of different functions. For example, the randint function is going to take two values, for example 1 and 20, and then we're going to get back a random integer between the first value and the second value. So here, for example, a value of 15. And if we run the exact same program again with a value of 1 and 20, we can see this time we get back a different value, 17 in this case, because again those numbers are generated pseudo-randomly. Of course, we can also have different lower and upper bounds. For example, here a value of 100 on the lower side and a upper value of 200. And then we're going to get a random integer between 100 and 200. Now, sometimes when we work with random or rather pseudo-random numbers, we want to make sure that we can test our code with the same random numbers. This may be helpful if we have some random numbers where we see a bug, and with other random numbers it works properly. Now, rather than having to run the code over and over again until we get the same random numbers, there's actually a way to fix those random numbers and to work with the same random numbers again. And to do that, we can use the seed function that we briefly saw before. We simply pass a value to our seed function, and by passing the same value to the seed function, we're going to get back the same random numbers. And to better understand that, let's first define a list. We are going to call it numbers, and the list is going to be empty. And then we're going to use a for loop to loop a total of 20 times. And we're going to add something to our empty list by using the append function. And we are appending a random number between 1 and 10 by calling randint, which of course is part of the random module. Now let's have a look at numbers. And we can see we get those random numbers back. So a total of 20 different numbers that were randomly generated between a value of 1 and 10. Now we saw before, if we run the randint function again, with the same input, we most likely are going to get some other output. But if we want to fix this, we can actually use our seed again with a value of 42. So to show that, let's call seed again with a value of 42. And then again, we're going to basically repeat the same steps as up here. So we are going to define an empty list and call it numbers. And then again, we are going to use a for loop, and we're looping over 20 times. And again, we're going to append a random number between 1 and 10. Now we would assume that those numbers inside of our numbers list are now different from the original one, because again we are generating random numbers between 1 and 10 20 times, so the chance that they are identical is extremely low. However, since we used the same seed here and here, so right before we were actually defining our numbers list and then calling random.randint, we actually get back the exact same values. So if we have a look at numbers, we can see we have the exact same values in here, even though we defined a completely new list and called randint 20 times for each of the different lists. Now if we switch back to our program, we can see that we are using the seed function here at the very beginning of our main function, and we passed a value of 42 to it, just to make sure that if any of those 20 messages that we are looping over did not encrypt properly, meaning if this message here is not equal to the decrypted message, then it will be a lot easier for us to debug the code, because of course with the random seed function here, we get back the exact same random values each time, so it is a lot easier to see where the issue may be. Next up, we're using the randint function that we learned about, and we are getting back a random value between 4 and 40 inclusive, and we're multiplying the alphabet here with this random number, so we're going to repeat the entire alphabet here between 4 and 40 times, depending on which random value is generated, and we are storing that back in our message variable. Now after that, we are taking our message string and we're turning it into a list and storing the resulting list back in the message variable. Now variables store lists differently than they store other values. Specifically, a variable will contain a reference to the list rather than the list itself. So when we work with lists, we basically always use references that point to that list. And to make the difference clearer, let's have a look at how we store, for example, strings and integer values. So here we have a variable spam and we assign an integer value to it. And then we can take that value and assign it to a new variable, for example, cheese. And then we can set the original variable spam to a different value, for example, 100. And if we then take a look at spam, spam is now going to have a value of 100 because that's the last value we set to spam. And if we have a look at cheese instead, cheese is going to have a value of 42 because here at this point, spam had a value of 42 and then we assigned that variable with a value of 42 to cheese. So only at the point where we assigned the variable, which at that point had a value of 42 to cheese, only that's relevant to determine the value of cheese. But let's have a look at how lists actually work. So let's again use a variable spam, but this time that's going to be a list of 6 different values, integer values from 0 all the way up to 5. And as before, we are going to create a second variable spam, and we're going to set spam equal to cheese. Now after that, let's update the value of cheese. In fact, we're going to change the second element, so the element at index 1, and we're going to change it from the value of 1 to the string hello. But note that we did not change the value of spam. Now if we then have a look at spam, we can see that even though we did not directly change the value of spam, spam has been updated. And of course, if we have a look at cheese, we can see the value for cheese is exactly the same. And the difference is that when we work with lists, variables pointing to lists always reference those lists. In contrast to variables using, for example, integers or strings that actually contain those values. So if we think that a variable is kind of like a box, we can see that for the variable spam here, our box, our variable, references this particular list, which in the beginning has a value of 0 all the way up to and including 5 as a list value. Now after that, we set cheese equal to spam. So that means now we have a second variable cheese, which is also referencing or pointing to that original list with a value of 0 all the way up to 5. So now as we update the second element inside of our list, the actual list will be updated. So now it has a value of 0, the string hello, and then 2, 3, 4, 5. And since both spam and cheese both point to that list, we can see that when we have a look at the value of spam or cheese, they're both going to give us back the exact same object here. So in both cases, we're going to get back 0, the string hello, and then 2, 3, 4, 5. And this behavior of working with references is especially important if we work with functions. And in general, we pass arguments to functions by value or by reference. So as an example, let's say we define a function called x that takes some argument, and we're going to simply append the string hello to that argument. If we then define a new list spam with the values 1, 2, and 3, we can pass spam as an argument to our x function, and we can then print out the value of spam. And note that our function itself actually does not print anything. So basically we have some operation that we perform inside of our function, but we don't do anything with it. So we don't reassign it to our spam variable, for example. So if we did this with an integer or a string, for example, then basically whatever change we performed here would be lost and our original variable would be unchanged. But since we pass lists by reference, if we have a look at the value for spam, we can see that spam actually has been updated. Because as we pass it as an argument to our function, the actual original spam variable has been updated, because again we just passed a reference to it and we made a change to it. So that's something to keep in mind. So we should always consider if we pass a list as an argument, which is passed by reference, and therefore the original variable can be changed, or if we pass an integer or string or some other value that's passed by value, in that case we need to make sure that we actually update the original value if we want to store the returned value. Now if you want to achieve though that we have two separate variables, that we have two separate list variables with separate values, and that they don't impact each other, we actually need to use the deepcopy function. So let's have a look at an example. Again, we're defining a spam variable with the same values as before. Then we need to import the copy module. And then rather than simply assigning spam to cheese, we need to call deepcopy, which is part of the copy module, and we need to pass spam to it. This is going to create a new copy of our spam list, which is completely independent of the original spam list. And we're gonna assign that to the cheese variable. Now, if we now update the value for our cheese list and we change the second element, so the value at index 1, we're actually only going to change the value for the cheese variable for our copy, not for the original spam list. So to verify, let's have a look at spam, and we can see that's indeed unchanged. We have the same values as before. But if we now have a look at cheese, we can see this one has been updated. And again, that works by using the deepcopy function here. So if we want to achieve the same as with integers or strings, we always need to use the deepcopy function. Now after this step in our program, we then use the shuffle function to actually rearrange the different letters of the string that we generated and then turned into a list. And to better understand how that shuffle function works, let's have a look in idle in our active shell. So here we're importing again the random module, and we have a list with the values of 0 all the way up to 9. And of course, if we have a look at spam, we can see those are the values here in the original order. However, if we use the shuffle function, which is part of the random module, and we pass spam to it, then we're basically rearranging the values inside of the spam value in a random order. So if we now take a look at spam again, we can see the order has been shifted, and we now have this order here. So that's an easy way to basically rearrange the different values. And in the case before, of course, we had different letters. So let's just assign that to the letters variable. We can then use the list function to turn our letter string into a list. So if we now have a look at letters again, we can see we now have a list of characters, and that's necessary because the shuffle function here only works on lists. And if we now go ahead and we pass letters to our shuffle function, and we have another look at letters, we can see that the order has been rearranged, so it's now a random order. And after that, we are simply using the join function to join the individual characters, which are now in a random order, back together. And this way we generate a string with a random order of letters. So to see that, let's generate a new variable random letters. And we're going to take an empty string, we're calling the join function on it. And of course here we are assigning our list of random letters to it. Once we've done that, we can take a look at the random letters, and now we can see they're joined together. So again, we have our string, and this is how we generate our random message. So now we learned about the new concepts and we know how our program works, our testing program. We saw, however, that all the 20 messages printed out that the encryption and decryption worked properly. But how do we know that our code is actually correct? For that, let's make sure that actually this if condition here evaluates to true, so that the original message is actually not equal to the decrypted message. And one way we can achieve that is by opening our encryption program. So this is our transposition encrypt.py program that we wrote 2 videos ago. And here, if we scroll down, we had this point here where we moved the index over. So here we increased the index by the key. And if you want to insert an error here, we could, for example, say we're just going to increase this by 1. So at this point, the current index is no longer correct. And then the encryption doesn't work properly. So let's save this change temporarily. Of course, we're going to undo that in a bit. And if we now switch over to our test program again, the program should actually fail. So let's run our program again. We are restarting it here, and we can see for the first test already, we see a mismatch with key 1 and the message, because here the decryption, if we have a look at that, that's different from the original message here. So therefore our program basically spotted the error. And of course we are only printing out test 1, because inside of our test code, if the message is not equal to the decrypted message, which of course is the case here, then we're going to print out the mismatch and the decrypted message, and then we are using the exit function here to actually stop execution of our program. So this is how we can verify that our code actually works properly. And of course we should open our transposition encrypt program again and remove this bug here. And once we've done that, we could just verify that our program works properly if we run it again now. And here we can see we are executing all the 20 cases and it works properly. Now let's have a look at the practice questions. And the first question here is, if we ran the following program and it printed the number 8, what would it print the next time we ran it? So here we are importing the random module, and then we are calling the seed function with a value of 9, and then we are printing out a random number between 1 and 10. And if we didn't have that second line here, we wouldn't know what will be printed out the next time, because that's random of course. But since we're using that seed function here, and we had the number 8 before, then if you run the same code again, and you're using the same seed again, we should get the exact same output. So again, we would get number 8 printed out to us. Now next up, the second question is, what does the following program print? So we have a list here, spam, with the values of 1, 2, and 3. Then we have a second variable x, and we point spam to x. Then we have a third variable ham, and we point that to x. And then we make a change to the first element inside of ham, and we set that to 99. And then we print out if ham is equal to spam. And of course we know, since we are working with list values here, that we are working with references to values. So by taking these steps here, we are basically pointing spam, x, and ham all to the same list with the values 1, 2, and 3. So that means as we reference the first element inside of the list that the ham variable points to 99, we are also changing the other two variables that point to that list. So spam and x, since they point to the same object, will also have 99 in the first position of the list they point to. So therefore, this here, ham is going to be equal to spam, and therefore this should print out true. Let's open idle and let's have a look at that in our interactive shell. So again, we define our variable spam, we point x to spam as well, and we point ham to x, and then we update the value of the first element in our list to 99, and then we're going to print out whether ham is equal to spam, and we see we get back value true. And of course we could have another look. If we take a look at spam, we can see 99 is indeed updated here for that list, and since they all point to the same list, it's the same for x and also for ham of course. The next question, which module contains the deepcopy function? So we know that the copy module contains the deepcopy function. Therefore, if we want to work with the deepcopy function, we always need to make sure that we import the copy module first, and then we could call deepcopy on copy and of course pass a value to it. And then finally, what does the following program print? Here we're working with the deepcopy function. We're importing copy. Then we have again a variable spam with the values 1, 2, and 3. And here we are creating a second variable x, this time by using our deepcopy function and copying this list here rather than just pointing to it. And we are repeating the same step again, using the deepcopy function by copying our copy of that list and assigning that to ham. And then we are updating the value of the first element of our ham list to 99, and we are checking whether ham is equal to spam. In this case, of course, the value should be false, because we are creating basically 3 different lists and they are completely separate. So we are not working with references here, but we have 3 separate list objects. So let's switch over to idle again and let's have a look at that in our interactive shell. We're importing the copy module, we're creating a new list spam with the values 1, 2, and 3, and then we are creating a new list using deepcopy, and we're copying the list spam and assigning it to a new variable x. After that, we are repeating the same steps here for our third variable ham, and we are copying the x list here as a new list. And then of course we are updating the first element inside of our ham list and setting it to a value of 99. And finally we are going to check if the list stored in the ham variable is equal to the list stored inside of spam, and here we get back false. So let's check again the values. Spam is unchanged, it has the values of 1, 2, and 3. X is also unchanged because again that's just a copy of spam and we didn't change either spam nor x. We only changed the third list ham. So if you have a look at ham, we can see that indeed has been updated. We learned how to write code that tests our programs automatically, and therefore we reduce the likelihood that we have any bugs in our programs. So far we've only encrypted short messages, but in the next video we're going to learn how we can encrypt and decrypt entire files. To stay up to date, feel free to subscribe to the channel and see you guys in the next video.